Okay. The expression you should get as the expression you should get after you solve all these equations are as follows. Got them? Good. So Pooja's got the right answer. Alright? Okay. So now, let's understand this. How do you think these solutions differ from the one in the previous case? First, Q1 क्या था previous case में? A, it would have been, so C1 and C2 it would have been. So it was A minus 2C1 plus C2 upon 3. Right? Now it is no longer A minus 2C1 plus C2 upon 3, but it is A minus 2C plus theta CH plus 1 minus theta CL upon 3. So how is this different from the previous one? So instead of the cost of the second firm here, we have the expected value of the cost of the second firm. Right? So theta CH plus 1 minus theta CL is the expected cost of the second firm. Right? So the first firm does not react not to the cost of the second firm, but the expected value of the cost of the second firm. Right? Okay. What do you mean? So how does Q2 star CH differ from the previous solution? Is Q2 star CH higher or lower than the quantity of output in the second firm in the perfect information case? Lower. Is it lower or is it higher? It's higher. Higher. Because CH is greater than CL. So this quantity is higher than this quantity. This is to be positive. So this actually is higher, right, than the cost of, than the output of the second firm. Whereas, what do you think of this? So the high cost firm produces more than what the second firm would have produced in a perfect information case. The low cost firm produces less than what it would have been in the in the perfect information case, and the first firm reacts to not the first firm thinks that because the first firm does not know the cost of production of the second firm, it substitutes that knowledge by replacing it with the expected cost of production of the second firm. Now, can you tell me why this is higher and this is lower? That is the crux of it. Now, let's debate that. Why do you think this is higher and this is lower? Then what would have happened in the full information case? So, will anybody want to give me an answer? Just think and talk about yourself. Why is that the case? क्या हो रहा है?
But in this firm, one expecting that high cost from the maximum level and low cost from minimum level. That is why we are saying that CH is high cost. As per his prior.
Can you put more structure? I think Amol has got the answer right, but he's not able to phrase it. So can somebody phrase the answer for Amol? Say Amol what you said again.
I said that firm 1 expect that firm 2 has maximum high cost and minimum low cost, which is he has prior information about the market. Now according to that he assigned probability there 1 theta and 1 minus theta. So high cost 1 minus theta and low cost theta. So according to expectation that firm's cost will vary. It will not exact high cost and exact.
I want you to answer why this is positive. Why what the high cost firm is producing, why is that greater than what it would have produced in a perfect information case? Why is the output of the low cost firm lower than what would have been in the perfect information case?
Because the cost of the high cost firm is lower.
Also the high cost firm is higher, no?
No, but you mean that Q1
Its cost should be lower. No?
What?
If high cost firm is producing more, then its cost
Yeah,
should
but
be lower.
that's not the case, no? That's why we call it a high cost firm.
No, but
CH is greater than CH. So let me understand these equations properly.
you are talking about Q1 will produce if Q2 have
So
high cost.
Q2 as a high cost firm is producing more than what it would have been in a perfect information case. So it is producing more than what it would have produced had firm 1 known perfectly surely that it is a high cost firm. Low cost firm is producing less than what it would have had the first firm known for sure that the second firm is that the firm is a low cost firm. No, they are moving simultaneously. What would be the answer? Think and chat. Yeah? See, what is happening is the first firm does not know what the cost of production of the second firm is. So it sets that equal to the expected value. Right? Somewhere midway between. So what it does is it produces less. It produces so what it's done is the first firm produces more than what it would have if it had known for sure that the low cost firm is a low cost firm. Because what the first firm is doing is, it is assuming that the cost of production of the second firm is somewhere between CL and CH. That's the expected value. So it is acting as if the cost of the low cost, that is, the cost of the firm is higher than CL but lower than CH. Because it is higher than CL, right? It is higher than CL. It is assuming that the cost is higher than CL. It is actually the first firm is producing more than what it would have had it known that the cost of the first firm is CL. First of the second firm is CL. So had the second firm known that the first firm known that the cost of the second firm is CL, right? It would obviously have produced less. Because now it thinks that the cost of the second firm is somewhere between CH and CL. It produces more than what it would have produced had it known that the cost of the second firm is CL. And because the first firm is producing more, the second firm, the CL is producing less. See, the first firm is setting its idea of the cost of the second firm between CL and CH. theta CL plus 1 minus theta CL. Theta is some number between 0 and it's an average of CL and CL, somewhere above CL, below CL. Now, if the first firm, so what did we see in the previous point? If the cost of producing the second firm is higher, the output produced by the first firm increases. Higher the cost of producing the second firm, higher is the output of the first firm. Right? So, the first firm is producing a more output related to what it would have produced if it had known that the second firm is of CL type. Because it now assumes that the cost of the second firm is actually above CL. So, it is the first one producing more. And because the first firm is producing more, Q2 star CL is less than what would have happened, what would have been produced, had the first firm known for sure that the second firm is a low cost firm. You see the point? Right? Now tell me why this is great. Yeah. Articulate the reason. Say that reason. Just think through the logic. Who will articulate why is this positive? Why is the output of the second firm, the high cost firm, higher in this asymmetric information case compared to what it would have been in a symmetric information case?
Had firm 1 known that the second firm is going to produce at a higher cost, it would produce less.
Okay. The second firm will produce less.
At firm
Yes,
one
but
known
CS
what
to be
is-
lower.
Yeah.
Had firm 1 known
Yeah.
that the second firm is producing at a high cost,
Yeah.
firm 1, it would have assumed firm 2 to produce less and therefore would have produced more itself.
Yeah.
But now because it assumes that the cost of the second firm is less than CH, it anticipates the second firm to produce more and then by itself produces less. Right? Because the key is higher is your cost, the lower is your production, and therefore higher. See, the response functions in a Purna model are increasing in the opponent's the competitor's cost and decreasing in the competitor's quantity. Higher the quantity produces with a competitor, lower is the quantity that you produce because too much quantity reduces prices, reduces profits, and so on. Right? So the argument here is that if the firm had known that the second firm is indeed a high cost firm, it would have expected to produce less and therefore itself would have produced more. But because now it thinks that its cost is lower than CH, it expects the second firm to produce more and therefore itself produces less relative to the perfectly symmetric information equilibrium. Is this clear?
So that means high cost firm will produce more and more to
Not more and more, it will produce a specific quantity.
okay. Specific quantity, that means which is that means firm 2 also anticipate that firm 1 what will produce.
No, firm 2, see this is a strategic interaction situation where firm 1 has to, we have learned to solve these through solving reaction functions, right? So firm 1, what firm 1 produces depends upon what firm 2 produces. What firm 2 produces depends upon what firm 1 produces. Right? And not because of some silly reasons like output more, etc. But because those are the reaction functions.
Right.
Those are optimal respect to each other which are derived from a first order optimization condition. Right? Please always learn to think in terms of optimization conditions, equations, etc. Not some silly idea that you read.
That means specific one point that firm 2 will produce.
Yeah, so what we saying here is, if firm 1 is uncertain about firm 2's cost, then it would produce less than what it would have produced had it, for example, if it doesn't know what the firm 2's costs of production are, if it doesn't know what the firm 2's costs of production are, but set those costs at an average value, the expected value of CL and CH, it only knows that it's going to be CL with probability theta, 1 minus theta, and CH with probability theta. So this number will be between CH and CL, right? Okay. So because the first firm then thinks that the second firm, if the second firm is a high cost firm, the first firm does not think that its cost is actually lower than what it is, because it's setting it as an expected cost, which is between CH and CL. So the first firm thinks that its cost is lower than what it actually is, and therefore it anticipates the second firm to produce more, right? It anticipates the second firm to produce more, which means, right, that it itself produces less, right? And that's why you get a positive quantity. Right? On the other hand, the reverse works for CL. Everybody gets this? You see that if CH and CL are the same, then you're back to the Nash equilibrium idea, the perfect symmetric information idea. Right? So if CH and CL are the same, then A minus 2CH upon C, so it will not matter CH and CL, and you would actually get the old solutions that you get. It's also very important. Okay. So you see this point? Right? The key point here is, we've got three equations, right? So we thought of type 1, firm 1 as of one type, firm 2 as being of two types, and then firm 1 forming certain expectations about what firm 2 would do, and then we solved the game. We solved the game, right? Okay, this is one example of a Bayesian Nash equilibrium. So what you have here, these solutions are what will be characterized as we go on by the idea of a Bayesian Nash equilibrium. Right? So do you understand the structure here perfectly? You have firm 1 is of only one type. Firm 2 can be of two types. They can be chosen randomly, right? That is, we can think of a big urn in which there is two types of firms, right? Firm 2, and one of them gets drawn with probability theta. Right? So nature draws a firm. Let's call it. Okay, a firm, the lower firm happens to be of type CL with probability 1 minus theta, and type CH with probability theta. So there are two types of firms there. What firm 1 has to figure out is, because what firm 1 is going to produce depends upon what type firm 2 is, firm 1 has to make expectations about what the type of firm 2 is. And there has to be specific expectations formation mechanism. Right? Okay? Sure? And therefore, and then we have to solve this game. We have to solve for the Nash equilibrium of such a game. We have to solve for the Nash equilibrium. But is the thinking through clear to everybody? Yes. That firm 1 has to figure in the respective probabilities. Okay? Right? Sure? Yeah.
So I don't understand with respect to the high cost. When the firm 1 is expecting.
See, when firm 1, suppose firm 1 had known that firm 2 was high cost firm. Then what would firm 1 have expected firm 2 to do? Produce less. So what would firm 1 have done? Produce more. But now, because firm 1 does not know that firm 2 is a high cost firm, it thinks its cost is somewhere between high and low. It thinks that its cost is lower than that of a high cost firm. Right? So therefore it expects that firm to produce more, and therefore it produces less. Right? Okay, so this firm produces more than what could have done in a perfect. So Q2 star of CH is actually more than what would have happened in a perfectly equilibrium case, and so that's it, right? Sure, is this clear, friends? Right? Logic, someone can answer? Oh. Right, so now so let me write down a big definition here now. Okay. So let's write this game in the normal form. What are the basic ingredients that are going to be there? Okay? Static in-person Bayesian game. What's a static game? Where moves are simultaneous. Right? A dynamic game is where there is a sequence of moves. Okay? Bayesian game. Okay? What is required? Okay, so what is required is first player's action spaces A1, A2, AN. A1 is what player 1 can do, various actions that player 1 can do in a set. A2 is a set of actions that player 2 can do. AN is a set of actions that player A. Right, this could be finite or infinite set. For example, what we did was Q1, the quantity produced by the first firm was the action space for the first firm, and that could have been theoretically 0 to infinity. That's an infinitely large set. So it could be a finite set or infinite set. Type spaces of players. So the various types that player 1 can be, various types that player 2 can be. Again, these could be finite or infinite sets, right? For example, I just said CH and CL, but I could think of any cost really. Cost is any number between 0 to infinity. Right? Okay, so P1. P1, P2, Pn are the beliefs that player 1, that players have. Right? They're actually probability distribution. So you have a probability distribution over agent types. So it says that player 2, for example, can be of type T1, T2, T3, T4, T5, etc. with various probabilities. So you need to have a probability distribution over each of the players' types. Right? That is the beliefs. Right? That is the beliefs. Okay? For so we'll write these beliefs as so what is it? The beliefs are really the conditional probability T minus I are the types of all other players except the ith player. T minus I is the type set of all other players except the ith player. Right, so what it says is the beliefs are the probability of the belief of the ith player that other players are of certain types given that player specific type. Okay, conditional upon that player's type. So you have to have, you know, your own type, and so you have beliefs over the the types of probability with which other players have specific types, given that you know your own type. Right? So the beliefs are conditional probabilities. Right? Conditional probabilities are the beliefs. Right? And because they are formed by conditional probabilities, the conditional probabilities will be formed by using Bayes rule. The conditional probabilities will be formed by using Bayes rule. This is called the Bayesian gate. Right? This is called the Bayesian gate. Okay? Right. So, and the payoff functions.